Hey guys, Miss Gosling here. In this video, we are going to talk about parallax angle. By the end of this video, you'll be able to use parallax angle to determine astronomical distances. So you're going to be able to use parallax angle to determine how far away stars are from us. So let's go ahead and get started. So our IB understandings, applications, and skills, you should be able to understand stellar parallax and its limitations. That's something that's very key. So make sure you're paying attention for the limitations of stellar parallax. And you should be able to describe the method to determine distance to stars through stellar parallax. And I'm going to go ahead and I'm going to underline that word describe. That means you need to, and because in IB physics, that can mean qualitatively by describing how we gain information about stellar parallax, and quantitatively, so the mathematics. So it's important when you're thinking through this video that you're paying attention to both the qualitative and quantitative descriptions I give on how we use stellar parallax to determine distance. So when I'm measuring parallax angle, what I'm looking at is how far a star moves according to our frame of reference on Earth. I can determine that angle by figuring out the star's relative position at 2 moments in time 6 months away from one another. So say I want to find the parallax angle for a star, for this red star right here. If I take my measurement of its location relative to all of the background stars, so that's every other star in this picture, if I do that in January, and then 6 months later I come back in June, and I take the same picture of that star against the background, I can see that that star has moved some distance across the sky. When I am looking at that distance is going to be relevant to my parallax angle here. So my parallax angle P. My parallax angle is proportional to the distance that I am from the star. And specifically, my distance from a star in parsecs, D, is equal to 1 divided by my parallax angle P, which is measured in a unit called arcseconds. And just so you know, 1 arcsecond is a tiny, tiny fraction of a degree. So looking at this, you might be able to guess some of the limitations of parallax angle. So take a moment and think. If 1 arcsecond is less than 0.0003 degrees, and distance is 1 over degrees, take a moment and think. If a star is really, really far away, like hundreds of parsecs away, what will its parallax angle be in degrees? And can you measure something with that angle? So pause the video and think. What do you think is one limitation of using stellar parallax to figure out the distance of stars? Okay, so hopefully you realized that if a star is too far from Earth, and that's the wrong 2. If the star is too far from Earth, then its parallax angle could be too small to measure. So remember, right, D equals 1 over P. If my parallax angle is 3 arcseconds, that's still a very small fraction of a degree. And so if my distance is very, very far, then I may not be able to measure that parallax angle with the tools that I have on Earth. So that's the first thing. Again, too far. So if star is too far, then we can't measure its parallax angle. A second really important limitation is that we cannot use it to find the distance of other astronomical objects like planets. So if we look at our near neighbors like Venus or Mars, the planets close to us, they are also in motion around the sun. As a result, I can't use parallax angle to find those distances because their motion relative to the Earth is very, very significant. So let's take a moment and do an IB example of a problem involving parallax angle. Mintaka is one of the stars in Orion. The parallax angle of Mintaka, measured from Earth, is 3.64 times 10 to the negative 3 arcseconds. Calculate in parsecs the approximate distance from Mintaka to Earth. So looking at A, what I'm being asked to do is, highlighting that IB term, calculate. So when I see the word calculate, I should immediately start thinking, what equation is going to help me? So this is, I'm given parallax angle. So givens, my parallax angle P is 3.64 times 10 to the negative third arc seconds. And I'm being asked to calculate, let me go ahead and add the word unknown here. I'm being asked to calculate the approximate distance, d, in parsecs. And since I'm asked to calculate it in parsecs, I know when I go from arc seconds to, when I go from parallax angle to distance, that distance is given in parsecs, so I won't have to do any unit conversions. So, moving on to my equation, I know my equation for distance is 1 over my parallax angle. Thus, my distance is 1 divided by 3.64 times 10 to the negative third arc seconds, or 275 parsecs, PC. And there is my answer for A. So what I'd like you to do, pause the video, take a moment, think, what about this problem, the way that it's worded, the way the information is given, might trip you up if you were asked to answer out this kind of question on the test. Okay, hopefully you've thought of a couple of ideas. Now let's look at part B. So you are asked to state, and I'm going to go ahead and highlight that IB command term, state, why there is a maximum distance that astronomers can measure using stellar parallax. So this one I want you to try on your own, pause the video, and tell me, why is there a maximum distance that astronomers can measure using parallax? So take a moment and check your answer. Hopefully what you had written down is that if your distance was too large, the parallax angle would be too small to measure. Take a look at my answer and make sure that yours matches. So let's go ahead and talk takeaways. First of all, parallax angle is used to find the distance from the Earth to nearby stars. Second, we have to be careful with units. Parallax angle is measured in arc seconds and is inversely proportional to distance, which is measured in parsecs. So we're looking at arc seconds and parsecs, not light years, not meters, not kilometers, not AUs. And third, the difficulty of measuring small angles is a significant limitation to using parallax angle to measure the distance of extremely distant stars. So hopefully this all made sense. Go ahead and try some parallax angle problems on your own. Best of luck and happy solving.